Hello all. So today we will discuss about the non-homogeneous linear system. So this is our given non-homogeneous linear system, dx by dt equal to a11 t of x plus a12 t, sorry, this is a12 of t y, then f1 of t, then dy by dt equal to a21 of tx plus a22 t of y plus f2 of t. So consider this non-homogeneous equation. For an ordinary differential equation, so if you are having a non-homogeneous linear differential equation, so you have seen that the solution is of the form y equal to yc plus yp, where yc is the general solution of the associated homogeneous equation and yp is a particular solution of the non-homogeneous equation. So the solution for a non-homogeneous linear system is similar to this. So we will see theorem on what is going to be the solution. Okay, so we have a theorem. So let x equal to f naught t and y equal to g naught t be any solution of the non-homogeneous equation non-homogeneous system and let us take x equal to f of t and y equal to g of t be any solution of the corresponding homogeneous equation. Then the theorem states that then x of t equal to f of t plus f naught of t and y of t equal to g of t plus g naught of t is also a solution of the non-homogeneous system. So this is the analogous theorem in the case of a non-homogeneous system. So if you have any solution of the non-homogeneous system and a solution of the associated homogeneous system, then its sum is going to be a solution of the non-homogeneous system. So x of t equal to ft plus f naught t and y of t equal to g of t plus g naught of t will again satisfy the non-homogeneous system. And now we will look at what is the general solution of a non-homogeneous system. ഇനി നമ്മൾ associated homogeneous equation എടുക്കുമ്പോൾ it will have a pair of two linearly independent solutions. So with that we will write the general solution now for the associated for the non-homogeneous equation. So we will look at now the general solution of a non-homogeneous system. So let x equal to f naught t and y equal to g naught t be any solution of the non-homogeneous system And now we will consider the two solutions of the associated homogeneous equation, two linearly independent solutions. So, and let x equal to f1 of t and y equal to g1 of t and x equal to f2 of t, y equal to g2 of t be two linearly independent solutions of the associated homogeneous equation and let C1, C2 be two arbitrary constants. Then the general solution is given by, so then x equal to C1 F1 plus C2 F2 of t plus F0 of t and y equal to C1 G1 of t plus C2 G2 of t plus G0 of t is called, so that is called the general solution of the non-homogeneous system. So this is called the general solution of the non-homogeneous system. So that is the general solution of the non-homogeneous system. So the most general solution of the non-homogeneous system is obtained as this part, so which is the general solution of the associated homogeneous equation plus f naught of t varum plus g naught of t varum, which are the particular solutions or any solutions of the given non-homogeneous system. So so we have seen a few set of basic theorems. So let us do a problem. Okay, so consider the linear system dx by dt equal to 3x plus 4y and dy by dt equal to 2x plus y. So the question is to show that x equal to 2 e raised to 5t and y equal to e raised to 5t and x equal to e raised to minus t, y equal to minus e raised to minus t are solutions of the system. And then second part is show that solutions are linearly independent and write the general solution. And the third part of the problem is find the solution. X equal to f of t and y equal to g of t such that f of 0 is equal to 1 and g of 0 equal to 2, and you need to explain why the solution is unique and over which interval it is defined. So this is the problem. Okay, so here you are not finding any solutions, so that will come in the coming classes, how to find the solution. So here we are just verifying the solution, then you are asked to show that they are linearly independent and how to find a solution under a given set of conditions. Okay, so let us first show that the given values of x and y, they are actually solutions. So you are given first x equal to 2 e raised to 5t and y is equal to e raised to 5t. So let us take first 3x plus 4y. So 3x plus 4y will be, so that will be 6 e raised to 5t plus 4 e raised to 5t. So that is equal to 10 e raised to 5t. So dx by dt is equal to, so that will be 10 e raised to 5t. So therefore dx by dt is equal to 3x plus 4y. So both are equal. So the first equation holds. Now let us so we have dy by dt equal to 5 e raised to 5t and again 3x plus y 11. Okay, so this will be equal to 2 e raised to 5t. So that is 2 into 2 e raised to 5t plus e raised to 5t. So this is 2x plus y. So therefore dy by dt is equal to 2x plus 5. So therefore x y equal to, so 2 e raised to 5t, e raised to 5t is a solution. So let us now check for x equal to e raised to minus t and y equal to minus e raised to minus t. ആദ്യം dx by dt എടുക്കുമ്പോൾ that will be minus e raised to minus t and 3x plus 4y will be 3 e raised to minus t minus 4 e raised to minus t. So that is minus e raised to minus t. So therefore dx by dt is equal to 3x plus 4y. Dy by dt is e raised to minus t varum. So that will be equal to 2 e raised to minus t minus e raised to minus t. So that is e raised to minus t. So therefore dy by dt is equal to 2x plus y. So therefore the pair e raised to minus t minus e raised to minus t is a solution. So that is a solution. So therefore the first part is proved. So therefore the given pairs are solutions to the equation. So the first part is proved. So let us now check whether they are linearly independent or not. Okay, so that is part B. So for that you need to find the Wronskian. So W of t is so that will be f1 of t, f2 of t, then you have g1 of t, g2 of t. So that is equal to determinant. So that will be 2 e raised to 5t, f2 e raised to minus t varum, then e raised to 5t and minus e raised to minus t. So that will give you minus 2 e raised to 4t minus e raised to 4t. So that is minus 3 e raised to 4t, which is not equal to 0 for any t belongs to R. So therefore the solutions are linearly independent. So the Wronskian is always not equal to 0. So solutions are linearly independent. And next we need to write the general solution. So therefore the general solution will be, so x of t will be equal to c1 f1 plus C2 F2, so that will be C1 into 2 e raised to 5t plus C2 e raised to minus t, and y of t will be C1 e raised to 5t plus C2 minus e raised to minus t. So that is the general solution. And now the third part is, so we need to find out the solution such that f of 0 is equal to 1 and g of 0 is equal to 2. So f of 0 equal to 1 and g of 0 equal to 2, that means at t equal to 0 this equation is equal to 1, and at, so this is going to be our f of t and this is going to be the g of t. So f of 0 equal to 1 implies, so ഇവിടെ 1 വരും, so you will have 1 equal to 2 c1, so t is 0, e raised to 0 is 1, 2 c1 plus c2 വരും, and g of 0 equal to 2 implies 2 is equal to c1 minus c2. So adding this you will get 3c1 equal to 3, so therefore c1 is equal to 1, so that will give c2 equal to, c2 will be c1 minus 2, so that will be equal to minus 1. Now last ചോദിച്ചിരിക്കുന്ന രണ്ട് questions ഇതാണ്, why is the solution unique? അപ്പോൾ for that use the basic existence and uniqueness theorem. Coefficient functions എല്ലാം they are all continuous throughout the real line, so therefore it definitely will have a solution, and on what interval it is defined, so it is defined throughout the real line. So those are the answers for the question. So let us stop with this for today. Okay then.